And how to write the expression for this circuit. Assalamualaikum dan selamat datang. Dalam video ini saya akan menerangkan tentang Boolean algebra dan juga logic simplification. Video ini akan menerangkan secara ringkas dan sangat padat mengenai kedua-dua perkara ini untuk digunakan di dalam kursus Digital Logic Design Lab. Okey, bersedia? Jom kita mulakan. Baik, di dalam slide ini saya ingin menerangkan tentang how to write the Boolean expression ataupun Boolean equation if you have the circuit. Okay, so for example here we have several gates, 2 OR gates, 1 AND gate and 1 NOT gate. Okay, and then how to write the expression for this circuit. Alright, so as the mention here, we start from left to right. Alright, first we determine the input going to the circuit. Okay, we have the A, B and C. Alright, and then take a look at the first OR gate here. Alright, the input of the OR gate is AB, so of course the output is A plus B. And then the second OR gate, the input is B bar. How it come B bar? Because we have the inverter here. To invert the input B become B bar. And then the output from the inverter is input to the OR gate. So the output of the OR gate becomes B bar plus C. Okay, and then both output of the OR gate here is going to the AND gate. Alright, and then we get the output of the AND gate equal to A plus B dot B bar plus C, or the bracket here determine that it is a AND operation between the two inputs. Alright, okay, next slide is about reverse operation of the previous slide. Okay, how to draw a logic diagram or a conventional logic circuit if you have the Boolean equation or Boolean expression. Alright, the first method is to determine the inputs, and then the second method is to determine which operation is performed first. For example, in mathematics, if we have the operation in the bracket, we solve the operation in the bracket first, right? And then after that, if we have the multiplication operation and addition operation, we will perform the multiplication operation first, and then after that we perform the addition operation. Okay, the concept is applied into the digital logic design. Okay, but when we have the AND operation, so we will doing the AND operation first, and then after that the OR operation. Okay, okay, the third step is insert appropriate logic gates. Okay, you have to know what logic operation is applied to the circuit, whether it is a NOT operation, OR operation, or AND operation, where we need the AND gate for AND operation, or maybe we can use the NAND gate, NOT gate, and also the XOR gate. So it depends what operation is involved in the Boolean equation. And then finally, we draw the connection between the logic gates. Okay, here is the example how to draw the circuit if you are given the Boolean expression. We have the expression X equals to A plus B bar dot C. So from here, remember what I said? Which operation is performed first? Yes, the AND operation. Alright. Before that, the first step is determine what is the input going to the circuit. So we have 3 inputs, A, B, and C. I just write down all the input A, B, and C. So because the first operation is AND gate, and then the input of the AND gate is B bar dot C. So we need the inverter to invert B become B bar. So the output here equals to B bar, and then the input, the B bar and C is input to the AND gate. Alright, and then after that the output of the AND gate is OR with A. Okay, so we get the output X at the end of the OR gate. Alright, next, example number 2. Y equals to A plus B bar dot C. So, which operation perform first? Yes, very good. The equation in the bracket. Alright, what is the input involved here? A, B, and C. And then the in bracket is A plus B bar. So, we need the inverter here. The output of inverter is the B bar. And then the B bar is OR with A. Okay. So, put the OR gate here. And then the output of the OR gate, this is the OR gate operation. And then the output of the OR gate is AND with C. So, we need AND gate. And then we get the output Y here. Okay, it's very easy. Alright. Next topic is about how to develop a truth table from Boolean expression. Okay, I jump directly to the example. So we have the equation Y equals to A plus B bar dot C. How many input we have here? We have 3 inputs, A, B, and C. So you need to list all the possible inputs. Okay, if we have 3 inputs, 2 power of 3 equal to 8, right? So we have 8 possible inputs. Okay, so if we have 2 input, let's say A and B, so we 2 power of 2 equals to 4. So you have 4 possible inputs. All right. I already draw the table for the input. Okay, so actually the 8 possible inputs is the combination of the binary number from 0 until 7. So we have 0, 0, 0 equals to 0 in decimal, 0, 0, 1 is 1, 0, 1, 0 is 2, 0, 1, 1 is 3, 1, 0, 0 is 4, 101 is 5, 110 is 6, and 111 is 7. Okay, and then the output Y. I will teach you the express way how to write down the output. All right. Okay, first look at the first term at the equation Y. So we have A. Okay, here is this column is represent input A. The second column represent input B, and then the third column represent input C. Okay, we go back to the A. Okay, so if the equation using A, so meaning that in the table we use value 1. Okay, if the equation using A bar, so meaning that in the table we use bit 0. Okay, here we have A. What about B and C? Okay, listen carefully. For this equation A, all right, you just ignore the B and C. Okay, just find A in the truth table and then label the output equal to 1. Okay, look at the truth table. A equal to 1 is here. So it doesn't matter what is the value of B and C here. So you just write down the output of Y equal to 1. Alright. And then next, we go to the second term. B bar and dot C. Okay. Okay, at the truth table, we find B bar dot C. Okay, so we have here, this is B is 0, C is 1. So actually this one is equal to B bar dot C. And we also have another one here. B bar dot C. 0, 1. B equals to 0, C equal to 1. B bar dot C. But for this row, we already mark the output equal to 1. So no need to make it another one. So just leave it there as a 1. And you just add the output 1 here. Okay. And then for the others input, it is equal to 0. Okay, next we will discuss about simplifying logic circuit. The objective for simplifying the logic circuit is to reduce the logic circuit so that we have the simpler form of the equation, and also to reduce the number of gate we will use in the circuit. Right? There are two methods for simplifying. We have Boolean algebra. This method using knowledge from the previous lab. You already know about the Boolean theorem and De Morgan theorem. So you will apply both theorem to simplify the logic circuit, and we call this method as a algebraic simplification. The second method is Karnaugh map. Okay, this is the very systematic and step-by-step approach, all right? And you will get the same answer, all of the student. If you follow the correct step, you will get the same answer for the kind of map. But in the algebraic simplification, it is depends on your skill and which Boolean theorem or De Morgan theorem you apply first. And then the answer can be different between each student. Okay, here we have the example of the original circuit and the simplified version of the original circuit. Okay, method 1, algebraic simplification. Perform algebraic manipulation resulting in a complexity reduction. And this method relies on your skill. Okay, in order to simplify the expression, you can expand first or you can factorize first if needed. Okay, so there's no systematic approach. It is depend on which Boolean theorem or which step you want to doing first. Okay. Okay, this is the example for algebraic simplification. We have the original equation z equal to a dot b bar dot c plus a. Okay, so we can see here a and b is sharing the same bar. Okay, so according to the De Morgan theorem, you have to separate this bar, okay, to become individual bar for a and b. Okay, so remember De Morgan theorem, a dot b bar equal to a bar plus b bar. Because of that, we can write the equation like this. After that, we have the AND operation here with the equation in the bracket. So we need to expand the equation. So it's become A multiplied with A bar multiplied with C and B bar multiplied with C. And then we get this equation A bar dot C plus B bar dot C plus A. Alright. So from here, I just rearrange the equation here so that we can simplify this part. Okay, you can refer to the Boolean theorem I give in the notes during lab 1. Please refer to equation number 11 in the Boolean theorem. So we have in the Boolean theorem a bar b plus a equal to a plus b, right? By referring to that theorem, we can simplify this equation. A bar dot c plus a becomes a plus c, and then we put another equation here, b bar dot c. Okay, from this equation we can factorize because we have c plus b bar dot c. Okay, we can factorize the equation, bring out the c, and then we have a plus c dot 1 plus b bar. And that, okay, refer to the Boolean theorem. Anything or with 1 will be 1. So we have b bar plus 1 here. So the equation in the bracket will be 1. Alright, so finally we get the answer A plus C. Okay. Okay, for the second example, we have the equation Z equal to A bar B bar C plus A bar BC plus ABC. Alright. To simplify this example, we can factorize. Okay. Let's say I choose here these two equation. So I choose to factorize BC. Alright. And then we can write the equation like this. And then remember in the Boolean theorem, A plus A bar equal to 1. Right? We simplify the Z become this one. Okay. We can factorize C. So we get the equation Z equal to A bar dot B bar plus B dot C. Okay. And referring to the Boolean theorem number 11. So here we have B plus B bar A bar. And then we can, by manipulating the equation from the Boolean theorem, so we can say the output equal to B plus A bar. Okay, I write the simplified equation here, A bar plus B. The second method is a karnaugh map, or we call it as the K map. Alright, what is the K map? Okay, actually it's a grid of squares, and the square is representing each input in truth table. Alright, if you have 8 possible inputs in the truth table, so you have 8 cells or 8 grid of square in your K map. Okay. In example 2, the equation is y equal to ABC plus A bar BCD bar plus CD. Okay, so we have 4 inputs, A, B, C, and D. Alright, so for 4 inputs, 2 power of 4 equal to 16. Alright, so for you have 4 variables, 4 input variables. It is equal to 16 possible inputs from 0, 0, 0, 0 until 1, 1, 1, 1. Right? Okay, so referring to the equation, look at the first term, ABC. So find the ABC in the truth table and then mark the output equal to 1. The ABC in the table is here. Okay, so we can, and also this one, ABC. Doesn't matter what is the value of D, just ignore the D. Alright, so you mark the output equal to 1. And then go to the second term, equal to A bar B C D bar is 0, 1, 1, 0. So 0, 1, 1, 0 in this table is here. So we mark 1 at the 0, 1, 1 at input 0, 1, 1, 0. Okay. Next term is CD. Okay, so you just find the value of CD equal to 1 and then just ignore what is the value of A and B. Right? CD is here. C equal to 1, D equal to 1, and then also here C equal to 1 and D equal to 1, and another one here, and also another one here. So for this row, we already mark the output equal to 1, so no need to mark it again. So we can put the output in the truth table like this. Okay, so here you can see the value of AB is 0, 0, 0, 1, 1, 0. No, it doesn't matter what is the value of AB, just ignore it. Okay, just find the value of the C equal to 1 and D equal to 1. Okay, and then for others output is equal to 0. Okay, after you write down the truth table, and then you have to map the truth table into the K map. Alright, so we have 4 input with 16 possible inputs. So we need 16 cells. 16 cells meaning that we have 4 times 4 row and column. So we have 4 times 4 equal to 16 cells. Each cells represent each input in the truth table. Okay, for example, this cells is represent input 0000. This one. A equal to 0, B equal to 0, C equal to 0, D to equal to 0. So this cells is represent input 000, and this cells is represent input 0001. This one. Okay, and then this cell is represent input 0011. This one. Okay, how to mapping the output from the truth table into K-map. So we find the input with output equal to 1. Okay, so the first one is this input 0011. Okay, 0011 is these cells, so we write down the output 1 here. Next is input 0110. 0110 is here, so we map value 1 into the cell, and then next input is 0111. 0111 is here, so we map the cells equal to 1, and then next is 1011. 1011 is here. Okay, so we write the value 1 into the cell, and next is 1110. 1110 here. Okay, so we write down 1 here, and finally is 1111. 1111 is here, so we write 1 into the cell. Okay, after mapping the output 1 into the K-map, don't forget to write 0 at the empty cell, like this one. Okay, alright, and then we continue with the next process, where we want to grouping the big one. So the grouping can be, I show to you the next slide. Okay, the grouping can be a group of 2, okay, like this one, or can be a group of 4, okay, like this one. We have many patterns how to doing a group of 4, or also it can be a group of 8, like this one. Also can be group of 16. Let's say all the value in the cell is 1, so you can group all the bit 1, so it's become a group of 16. Okay, when you want to group the K-map, you only can group the isolated group, which is there's no adjacent cells with value 1. Okay, and or you can make it as a group of 2. Okay, and the group, or a group of 4, a group of 8, and group of 16. We follow the rules of 2 power of n. Okay, the number of group. 2 power 0 equal to 1, so you can make it isolated. 2 power of 1 equal to 2, so you can make it group of 2. 2 power of 2 equals to 4, 2 power of 3 equals to 8, and 2 power of 4 equals to 16. You cannot make it as a group of 3, group of 6, group of 5, cannot. Okay, because you have to follow the rule 2 power of n. Okay, and then another rules to group the big one is you can group it in horizontal or vertical group only. You cannot make it as a diagonal, like this one. You cannot make it as a diagonal grouping. Okay, or like this one. Okay, you only can group it with the cells in the left or right, or with the cell at the above or below of the cell. Alright. Okay, so let we group the big one, and then before that, our aim is to find the biggest loop or biggest group as you can, because the bigger the loop, the simplest the equation. Okay, so here we cannot find the loop of 16, and also group of 8 is not here, and then we only can see the group of 4. Okay, where the group of 4 is this one, group of 4. All right, oh yeah, it's better, group of 4. And for this group, the equation is to write down the equation, we just take the same variable and ignore the different variable. Okay, for example here, for this group, okay, we look at the row here. Okay, actually this one is a bar, b bar, a bar, b, this one is a b, and this one a b bar. And also same here, if you already print your notes, your slide, you can make a correction. Actually it is correct, but the bar is too small and you cannot see the bar. Okay, so go back to this loop. This loop cover all rows. Okay, this row, this row, this row, and this row. Okay, when you see this row, look at the variable a. The value here is a bar. This one is a bar. This one is a, and this one is also a. For all the rows, the a is not same. We have a bar and a. Okay, so we ignore the a. Same with b, we have b bar, b, b, and b bar. It is not. You should have all variables same. For example, if the variable is b, all row is b. Okay, but in this case, we have some row equal to b bar and some row equal to b, so we cannot take it is as the equation, so we ignore the a and b. And then we refer to the column. The variable involved in this column is C and D, and all big one in that column have the same value, C and D. So the equation for this group is C and D. C the D. Okay. And next we still have a big one to group, and then we can make it as a group of 4. Okay, it is okay to overlap the group because our aim to find the biggest loop. Okay, so we can overlap the value, we can overlap the value 1 here. Okay, so that we can have the group of 4. Okay, how to write down the equation for this group? Okay, this row, the variable involved is a bar and b, and for this row is a b. Okay, so from here, which variable is same? Of course, b is same, because in this row we have b, and also this one we have b, but here we have a bar and a, so we can ignore a and take the b as the equation. Okay, next we look at the column. Okay, so the column involved is these two columns. All right, so the first column here is CD bar, and the second column here is CD. So from here, the same variable is C, and then we can ignore D. Alright. Therefore, we can say the equation for this group is equal to BC. From there, we can write the simplified equation equals to CD plus BC. Okay. With that, I finish my presentation. Okay, so for the last two slides is only the example how to make a group in the K-map, so you can refer to the slide after this. Hopefully this video can help you to finish your task, because I'm trying to make a very simple and compact presentation. Okay, that's all. Thank you and Assalamualaikum.